Hi everyone, this is Mr. Bowman, and this is the second AP free response question covering the topic of using integrals for accumulation. You'll notice that this is a calculator OK question, and we have a graph of a couple of functions here. So let's take a look at this. The amount of water in a storage tank in gallons is modeled by a continuous function on the time interval from 0 to 7 inclusive, where t is measured in hours. In this model, rates are given as follows. 1. The rate at which water enters the tank is f of t is equal to 100 t squared sine square root of t gallons per hour from 0 to 7 inclusive. 2. The rate at which water leaves the tank, g of t, 250 from time 0 to time 3 gallons per hour, and 2500 for time 3 to time 7. So as you can tell by looking at this, that the smooth function would be f of t and the step function would be g of t. So I'm going to label that as such to keep track of that. The graphs of f and g intersect at t equal 1.617. So this would be t equal 1.617. and t equal 5.076. So that's right around 5, so t is equal to 5.076. At time t equals 0, the amount of water in the tank is 5,000 gallons. How many gallons of water enter the tank during the time interval from 0 to 7? Round your answer to the nearest gallon. How many gallons of water enter the tank? So to find our answer to A, we are going to integrate from 0 to 7, f of t dt. Make sure your calculator is in radian mode, and when you integrate that, you will get that that is equal to the nearest gallon, 8,264 gallons. Again, to the nearest gallon, so you don't have to round to 3 decimal places. Let's take a look and see how they score that. 1 point for the integral and 1 point for the answer. So even though you're using your calculator to do this, you still have to show what you're doing. Part B says, for the interval from 0 to 7, find the time intervals, plural, during which the amount of water in the tank is decreasing. Amount of water in the tank is decreasing. Give a reason for each answer. Okay, so let's think about this. The water is flowing into the tank at f of t, gallons per hour. It's flowing out of the tank at g of t, gallons per hour. So if f of t minus g of t is less than 0, then the amount of water in tank is decreasing. Alright, so we can do this a few ways. An easy way to do that would be graph f of t minus g of t, but you got to be careful because at t equal 3, g of t changes from 250 gallons per hour flowing out to 2,000 gallons per hour flowing out. Instead of graphing f of t minus g of t and figuring out when that's less than 0, this statement is equivalent to saying f of t is less than g of t. So when f of t is less than 250 for time 0 to 3, or f of t is less than 2,000 for time 3 to 7, that would also be true. Now, you can actually figure that out by looking at the graph up here. So, from time 0 to 3, f of t is less than g of t. F of t less than g of t on the interval from 0 to where they intersect at 1.617. f of t is also going to be less than g of t. This one's a little bit trickier here. Remember, this is at t equal 3 here on the interval f of t less than g of t on the interval from 3 to 5.076. And remember, f of t is the rate at which water is flowing in, and g of t is the rate at which water is flowing out. So if f of t is less than g of t, then the amount of the water in the tank is decreasing. So our answers to that are the two intervals, 0 to 1.617, or 3 to 5.076. That's a parenthesis there. Let's take a look at the scoring of that. Let's see. The amount of water in the tank is decreasing on the interval from 0 to 1.617. Interestingly, they included the endpoints here. You definitely need to include the endpoint of 0. At 1.617, they're actually equal to each other. And at 3, I guess we don't have the rate that it's flowing out defined. So I would not have included the endpoints on the second one. I think that they would be generous for that. Oh, actually, the answer is right here, and that would be the answer that I gave. So 1 point for the interval, 1 point for the reason, and that accounts for 4 out of the 9 points in that particular problem. Which means that part C is going to account for 5 points, 5 total points. So don't give up on those parts. Work through them as best you can. So let's see what they're asking in part C. For the closed interval from 0 to 7, at what time t is the amount of water in the tank the greatest? Okay, so we're optimizing, we're maximizing that function. To the nearest gallon, compute the amount of water at this time. Justify your answer. First of all, it's a closed interval, so we have to include the endpoints. We're looking for a maximum, so we want to see where the derivative, we'll talk about the derivative of what, changes from positive to negative. So we're going to define W of t as the amount of water in the tank. There's initially 5,000 gallons of water in the tank, plus the integral from 0 to t of f of x dx. I'm using x just for a dummy variable. That's the amount of water that's added to the tank minus the amount of water that's taken out, integral from 0 to t of g of x dx. Alright, so the amount of water, Wt equals amount of water in the tank, is a max at endpoints t equal 0 or t equal 7, or where W prime of t changes positive to negative. So let's find W prime of t. W prime of t is going to be equal to, the derivative of 5,000 is just 0. The derivative of the integral from 0 to t of f of x dx is just going to be f of t by the fundamental theorem, and the same thing for the integral from 0 to t of g of t. So what we are basically looking at is, where does f of t minus g of t change from positive to negative? Another way of thinking about that would be saying W prime of t changes positive to negative, where f of t minus g of t becomes less than 0, or f of t becomes less than g of t. So we go up here and take a look at that, and remember, it's where f of t is changing from greater than g of t to less than g of t, and So excluding the endpoints, that's going to happen at t equal 3, because from t equal 3 on up to t equal 5.076, f of t is less than g of t, so f of t minus g of t is going to be negative, or w prime of t is going to change from positive to negative. Now, to illustrate that maybe in a different way, I have a graph here of f of t and g of t, and I'm just going to graph f of t minus g of t, and you will see the green function is f of t minus g of t changes from positive to negative at t equal 3. So in our candidates chart, we are going to have to find 3 values at t equal 0, 3, and 7 of w of t. And we do not have to relabel that because we actually defined that a minute ago. And that would be 5,000 at time 0. And it would be 5,000, I'm going to label it anyway, 5,000 plus the integral from 0 to 3 of f of t dt minus the integral from 0 to 3 of g of t dt, and you can do this on your calculator and find that that is 5,126.591 gallons. Similarly, from at time 7, you're going to start with what you had at time 3, 5,126.591, plus the integral, we're only integrating from 3 to 7 of f of t dt. So the amount that we started with at time 3 plus what was added minus what was taken away, the integral from 3 to 7 of g of t dt, and that turns out to be 4,513.807 gallons. So make sure you answer the question. And the question is, for what time from 0 to 7 inclusive is the amount of water in the tank the greatest? W of t, which we have defined, is a max at t equal 3. And we've already justified that with looking at w prime, where it changes from positive to negative at t equal 3, and the endpoints. And w of 3, it also asks what that is approximately equal to 5,122 gallons, because it says to the nearest gallon, gallons. And let's wrap this up by taking a look at how they would score that. So, identifies t equal 3 as a candidate, obviously a justification for that. F of t minus g of t changes sign from positive to negative. The integrand, I'm assuming they're talking about this part right here. We wrote an integral for this part as well, but we didn't have to. The amount of water at t equal 3, the amount of water at t equals 7. I'm not sure why you don't include the amount of water at t equals 0, and then finally a conclusion. The amount of water in the tank is greatest at 3 hours. At that time, the amount of water in the tank rounded to the nearest gallon is 5,127 gallons. And I'm not sure why I got 5,122. That's because I simply wrote it down wrong. It should be 5,127 gallons. So be careful about that stuff.